Good day, everyone. I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about multiplication of radicals. To multiply radicals of the same order, use the property nth root of a times b equals to nth root of a times nth root of b. To simplify by removing the perfect nth root powers from the radicands. Example number 1, we have square root of 2 times square root of 32. Since we have the same index class, you just need to multiply the radicands. We have a square root of 2 times 32. So that is square root of 64. Since 64 is a perfect square, so we have 8. Example number 2, we have cube root of 5 times cube root of 25. Since we have the same index, all you need to do is multiply the radicands. So we have cube root of 5 times 25. So we have cube root of 125. So cube root of 125, we can change this one into exponential form. We have cube root of 5 raised to 3. So we have 5 here. Next, we have square root of x raised to 4 times square root of x raised to 6. So by laws of exponent class, and you multiply a variable with an exponent, so we have here, we just need to copy the base and then add the exponent. So we have square root of x raised to 10. So next, to simplify this one, just divide the exponent to the index. Then copy the base first. So we have x is equals to 10 divided 2. We have x raised to 5. Fourth root of 4x cubed times fourth root of 12x squared. So all you need to do is to multiply. So we have here fourth root of 4 times 12. We have 48. And x raised to 3 times x raised to 2. Add the exponent, copy the base. So we have x raised to 5. To simplify this one, we need to factor 48. One of them must be a perfect square and one is a non-perfect square. So we have 16. Fourth root of 16 times 3, and then factor also x raised to 5. So we have x raised to 4 times x. To simplify, x raised to 4. So we have here fourth root of 16 x raised to 4 times fourth root of 3x. So what is the fourth root of 16? So we have 2. And then the fourth root of x raised to 4, copy the base x. And then 4 divided 4, we have 1. And then copy the remaining term in the radical. So we have fourth root of 3x. So your final answer is 2x fourth root of 3x. Next, we have square root of 7y cubed times square root of 7y raised to 5. So multiply. Just multiply the radicand. So we have 7 times 7, we have 49. Y raised to 3 times y raised to 5. Just add the exponent, y raised to 8. So what is the square root of 49? So we have 7. And then square root of y raised to 8, we have copy y. And then 8 divided 2, we have 4. So we have 7y raised to 4. Next, we have 5 square root of 18c times 3 square root of 27 c raised to 5. So multiply the whole number there. So we have 5 times 3 square root of 18c times 27c raised to 5. So we have 15 square root of 18 times 27, 486. C times c raised to 5. So c raised to 1 times c raised to 5. Copy c and then add the exponent. 1 plus 5, we have 6. So next, we just need to factor 486. One of them must be a perfect square and the other one is a non-perfect square. So we have 15 square root of 6 times 81. Since 81 is a perfect square, c raised to 6. So what is the square root of 81? We have 9. And then square root of c raised to 6, we have c raised to 3. And then copy the remaining term in the radical, square root of 6. So we have 15 times 9, c raised to 3 times square root of 6. So 15 times 9, we have 135, c raised to 3. square root of 6. So this is our final answer. Now, in multiplying radicals with different indices and the same radicand, there are steps to follow. First, we have to transform the radical to powers with rational exponent. Multiply the powers by applying the rule x raised to m times x raised to n is equals to x raised to m plus n. Rewrite the product as a single radical and then simplify the resulting radical if necessary. Example number 1, we have square root of 3 times cube root of 3. So we have different indices here but the same radicand. So again, next step, we need to transform the radical to power with rational exponent. So we have 3 raised to, our exponent here is 1. So your numerator will be 1. And your index here is 2. So we have 3 raised to 1/2. Times the base, copy the base 3. Then your numerator will be your exponent. So we have here 1. And then the denominator will be your index. So we have 3 raised to 1/3. So simplify, find the common denominator of 1/2 and 1/3. So we have multiply first, no? We have 3 times 3, we have 9. And then their common is 6. So 6 divided 2 is 3 times 1 is 3. 6 divided 2, we have 3 times 1. 6 divided 3 is 2 times 1, we have 2. So that means we have here 9 raised to 5 over 6. So change this one into radical form now. So we have our denominator here of the exponent is our index, 6th root of 9, your base, and then your numerator will be your exponent, 9 raised to 5. So simplify 9 raised to 5. So we have 6th root of 59,049. So that is the final answer. If this one cannot be simplified, so that's the final answer. Number 2, we have square root of 4 times 4th root of 4. So change this one into exponential form. We had 4 raised to 1/2 times 4 raised to 1/4. Find the common denominator of this one. Simplify first. 4 times 4, we have 16. Raised to 1/2 plus 1/4. So their common is 4. So 4 divided 2 is 2 times 1, we have 2. 4 divided 4 is 1 times 1, we have 1. So we have 16 raised to 3/4. And then we change this one into radical form. We have 4th root of 16 raised to 3. 16 raised to 3 is 4,096. That means we have 4th root of 4,096. We can find the 4th root of 4,096. So we can raise that one into 8 raised to 4 because 8 times 8 times 8 times 8, we have 4,096. And then to simplify this one, we can cancel this 4th root and then exponent 4. So we have the remaining answer here is 8. Next, we need to multiply radicals with different indices and different radicand. So first, we need to transform the radical to powers with rational exponent, change the rational exponent into similar fraction, and rewrite the product as a single radical. Simplify the resulting radical if necessary. So we have square root of 2 times cube root of 3. So we have different indices and different radicands. So change this one into powers with rational exponent. So we have 2 raised to 1/2 times 3 raised to 1/3. Next, we need to find the common denominator of this one. So we have here, their common is 6. So 6 divided 2, we have 3 times 1, we have 3. 6 divided 3, we have 2 times 1, we have 2. So since we had the same denominators, now change this one into radical form. And then we have here 6th root of 2 raised to 3 times 6th root of 3 raised to 2. Since we have the same indices now, we can multiply the radicands. But first, we need to simplify the radicand first. So we have 2 raised to 3. 2 times 2 times 2, we have 8. 3 raised to 2, we have 9. Now we can multiply this one. So we have 6th root of 8 times 9. We have here 6th root of 72. Next, we have cube root of 4 times 4th root of 5. So we have different indices and different radicands. So change this one into powers with rational exponents. So we have 4 raised to 1/3 times 5 raised to 1/4. Find their common denominator. We have 12. So 12 divide 3, we have 4 times 1, we have 4. 12 divide 4, we have 3 times 1, we have 3. So since we have the same denominators now, so change this one into radical form. So we have here 12th root of 4 raised to 4 times 12th root of 5 raised to 3. Simplify first the terms in the radicand. So we have 12 root of 256, that is 4 raised to 4, 256. 5 raised to 3, we have 125. Since we have the same indices now, we can multiply directly the radicands. So we have here 12th root of 32,000. So we can simplify this one. So this will be the final answer. Next, we need to how to multiply a polynomial radical expression by a monomial. So we have here a monomial here, square root of 5, and then a polynomial here, we have square root of 2 plus 4 square root of 5. So all we need to do is to distribute to simplify this one, no, to multiply each term. So distribute square root of 5. So we have square root of 5 times square root of 2 plus square root of 5 times square root of 4 square root of 5. So square root of 5 times square root of 2, we have square root of 10. Square root of 5 times 4 square root of 5, so copy 4. Square root of 5 times square root of 5, we have square root of 25. So we can simplify square root of 25, we can make it 5. So we have square root of 10 plus 4 times 5, we have square root of 10 plus 20. Example number 2, we have square root of y times 5 square root of y minus 2 square root of 3. So distribute square root of y to simplify. So we have here square root of y times 5 square root of y plus square root of y times negative 2 square root of 3. So square root of y times 5 square root of y, we have 5 square root of y squared. Since y times y, we have y squared. Plus square root of y times negative 2 square root of 3. So since we have here a negative sign here now, so we have now negative 2 square root of 3 times y, we have 3y. So we can simplify this one square root of y squared. So we have square root of y squared is y. So we have here 5y minus 2 square root of 3y. Example number 3. So we have 4 square root of 5 times 2 square root of 15 minus 3 square root of 6 plus square root of 3. So distribute 4 square root of 5 in each terms. So we have now 4 square root of 5 times 2 square root of 15 minus 4 square root of 5 times 3 square root of 16 plus 4 square root of 5 times square root of 3. So 4 square root of 5 times 2 square root of 15. So we have 4 times 2, we have 8. Square root of 5 times square root of 15, we have square root of 75. 4 times 3, we have 12 minus 12. And then square root of 5 times square root of 6, we have 30. So 4 square root of 5 times square root of 3, so we have 4 square root of 15. Now we can simplify square root of 75. Now we can factor that one into 8 square root of 25 times 3, since 25 is a perfect square, minus 12 square root of 30 plus 4 square root of 15. So we have here 8 times 5 square root of 3 minus 12 square root of 30 plus 4 square root of 15. So 8 times 5, we have 40 square root of 3 minus 12 square root of 30 plus 4 square root of 15. That is our final answer. Next, multiplying two polynomial radical expression. So if we have two binomials here, so a plus b a plus b times c plus d, so we will use FOIL method, no? First terms and then outer terms, and then inner terms, and then last terms. So we have here, example number 1, we have square root of 5 plus 2 times square root of 3 minus 4. So this will be our A, B, C, D. So, unsa ito? So we have the first term, so square root of 5 times square root of 3, and then the outer terms plus square root of 5 times negative 4, and then inner terms plus 2 times square root of 3, and then last terms plus 2 times square root of 4. So we have this one. Simplify now. So square root of 5 times square root of 3, we have square root of 15. Square root of 5 times negative 4, so we have negative 4 square root of 5. And then 2 times square root of 3, so we have 2 square root of 3. 2 times negative 4, we have negative 8. So we have here square root of 15 minus 4 square root of 5 plus 2 square root of 3 minus 8. Since this is the simplest form na, so this will be our final answer. Next, we have square root of 3 plus square root of 8 times 3 square root of 2 minus square root of 6. So this will be our A term, B, C, D. Unsa ito? First term, so we have 3 square root of 3 times 3 square root of 2. And then outer terms, square root of 3 times negative square root of 6. Inner terms plus square root of 8 times 3 square root of 2. And then the last terms plus square root of 8 times negative square root of 6. So simplify this one. So we have 3 square root of 6 minus square root of 3 times negative square root of 6. So we have negative square root of 18 plus 3 times square root of 16 minus square root of 8 minus square root of 6 times square root of negative square root of 6. We have square root of 48. So we can factor square root of 48 here. 16 times 3, since 16 is a perfect square. Simplify, and also we can simplify this one. Square root of 16, we have 4. So we have 3 square root of 6 minus 3 square root of 2 plus 12 minus 4 square root of 3. That is our final answer. Next, we need to multiply two polynomial radical expressions. So if your term will be a perfect square binomial, so by the rule of perfect square binomial, if we have a plus b squared, that means we just need to square the first term plus 2 times the first term times the second term plus the square of the second term. So for example, we have here square root of y plus 4 squared. So our first term is square root of y, and our second term will be 4. So again, what is the steps in simplifying perfect square binomial? We just need to square the first term. So we have square root of y squared plus 2 times the first term square root of y times 4 the second term plus the square of the second term 4 squared. So we have here square root of y squared, so we can eliminate the square root and the exponent 2, so we have y plus 2 times 4, we have 8 square root of y plus 4 squared, we have 16. So that is the final answer. Next, we have 2 square root of 3 plus 3 squared. So the first term will be 2 square root of 3, the second term is 3. So we have here 2 square root of 3 squared plus 2 times 2 square root of 3 times 3 plus 3 squared. So we have 2 squared is 4, and then square root of 3 squared is 3. So we have 4 times 3 plus 2 times 2, 4 times 3, 12. Square root of 3 plus 3 squared is 9. So simplify this one. So we have 3 times 4, that is 12, plus 9, we have 21, plus 12 square root of 3. So we have 3. Example number 3. So we have 3 square root of 5 plus 5 square root of 7 squared. So we have here now 3 square root of 5 squared plus 2 times 3 square root of 5 times 5 square root of 7 plus 5 square root of 7 squared. So we have here 3 squared, we have 9, and then square root of 5 squared, we have 9 times 5 2 times 3, we have 6 times 5, 30. Square root of 5 times square root of 7, we have square root of 35. Plus 5 squared is 25 and square root of 7 squared, so we have 7. So 9 times 5, we have 45, plus 30 square root of 5, plus 25 times 7, we have 175. So simplify 45 plus 175, we have 220 plus 30 square root of 35. Last one, now if the perfect square binomial difference a minus b squared is equals to a squared minus 2 times a times b plus b squared. So example number 1, we have square root of 3 minus 3 squared. So this will be our first term, and then the second term. So we have square root of 3 squared minus 2 times square root of 3 plus 3 plus we have here 3 squared. So we have square root of 3 squared, so we have 3 minus 2 times 3, we have 6 square root of 3 plus 3 squared is 9. So we have here now 3 plus 9, we have 12 minus 6 square root of 3. Last example, we have 5 square root of 5 minus 2 square root of 2 squared. So we have here 5 square root of 5 squared minus 2 squared times 5 square root of 5 times 2 square root of 2 plus 2 square root of 2 squared. So we have 5 squared is 25, square root of 5 squared is 5, and then 2 negative 2 times 5 negative 10 times 2 negative 20. Square root of 5 times 2, we have negative 20 square root of 10 plus 2 squared is 4, square root of 2 raised to 2 is 2. So 25 times 5, we have 125 minus 20 square root of 10 plus 4 times 2 is 8. So simplify, we have 133 minus 20 square root of 10. Okay, that's all for today. That I hope that you've learned something out of this video lesson. Please don't forget to like, subscribe, and if you have questions, please comment down. Thank you so much. God bless and goodbye everyone. Bye-bye.